Okay, second draft of this briefing. I just recorded the entire thing and then accidentally deleted it instead of sending it. So hopefully that's a good thing because it was a practice run and I'm going to do it way better the second time. Um, yeah, that was frustrating. Okay, let's dig into this. We've got, well, it's really quite a cool venue that we're at here. There's a lot to learn and it's a really dynamic race course, but it's not unpredictable. Like there's a lot of variables, but they're all predictable and they can all teach us something and there's something we can understand and learn from all of them. Um, we've got two different wind forecasts that I've seen for the day. The first one was a lot windier and more northeast, and the second one was a little bit lighter and more kind of straight out of the east. This briefing was based off the earlier forecast, which I don't think is going to be quite correct. Um, but we're going to go with it anyway because we'll probably see similar conditions throughout the regatta. We'll talk about both. Um, Sorry to be bouncing around. Let's just get into the interesting stuff. So here's the area we're at. We've got the opening to the ocean here. And then the sailing center in here and the race course up over here. Okay, we've got, this is some shallows that we want to watch for on the way in and the way out, which we learned the hard way yesterday. We knew we were there, we just got to pay more attention. This whole intercoastal waterway is full of shallow spots and deep channels, and so that's super relevant to the current, and there's a lot of stuff we want to watch out for. One super interesting thing about the race course is this gap here where the water can flow through here. It would be totally different the race course would be entirely different if this was blocked off. But because there's an open channel here, the current actually accelerates through this gap because there's so much water that has to pump through such a small opening. And you have a bit of deeper water here and increased current. And then same thing, of course, through your bridge, maximum current, and a deep water channel through here. And then relief caused by the shallow water here, and especially if the current is flooding, which is coming in exactly the direction the mouse pointer is locked at, then it's going to fully block that flood, and you're going to have a lot of relief here. And you have a cone to play, similar to like Alcatraz in St. Francis, where there's significant relief, current relief, down current of this bridge, right? And that depends on the wind direction, which we're going to get into. So both the wind and especially the current like to go in the direction of this channel. The current, of course, always does, whether it's flooding or ebbing. Okay, so flooding current is going to come exactly in the direction of the mouse pointer this way. And then ebbing current is going to go exactly the opposite. So today's current times are very easy to remember. It basically switches at noon. I think it's 12:06. Oh, it's exactly at noon. Okay, so right now, 9:15 a.m., we have peak flood current, water coming into the intercoastal waterway, and then at high tide it'll go slack, and then for most of the rest of the day, afternoon, we'll probably be launching around noon, hopefully, and we'll be sailing mostly in the ebb current today. Maybe we'll get out earlier than that. Okay, so right now, mid-morning, flood current pumping in the direction of the mouse. At noon, it'll be slack and relatively calm. And then for the rest of the day, ebb current ripping out the opposite direction of the mouse. Okay, so that's the current. It's either ripping in or ripping out. And then we'll study Navionics or the Garmin app, which you guys should all have. It's totally worth the subscription. It's not that expensive for what you get out of it, especially if you're racing sailboats. You should be looking at it at every venue you go to, really. We'll study that more in detail to get the finer aspects of what it looks like underwater here, and where's the shallow, where's the deep spots, because that's obviously going to tell you where there's more and less current, more current in deeper water, right? Yesterday we had a southeasterly wind that was blowing in this direction, the direction I'm trying to take the mouse pointer from, right here, this way. We had wind blowing in that direction. And we get two things when we have this southeasterly or this more northeasterly that can come through in this direction, okay? We have, in both of these cases, in the ocean, the wind is likely to be more easterly, and then the channel here has a funneling effect where it likes to funnel the wind in the direction of this channel. Okay, so there was a day last year at this regatta where the wind was blowing in this direction. Like if we use this angle of the coastline here as an arrow, the wind was probably in line with this. And on the left side of the race course, there was great pressure. There were just giant puffs coming straight down and funneling down the channel this way. And the right side of the race course was more light and shifty and funky. If that wind direction was slightly more to the right of this angle, to where it was more onshore and less down the channel, then we would have expected this funneling channel pressure to be less and go away, right? And what we've seen maybe more often is this southeasterly, which has exactly the same effects, just from the opposite direction. So if the wind's coming southeasterly, on the right side of the race course, you would tack and sail right into very steady, solid pressure that was funneling in line with the direction of this entire channel. But most of us know what we get if we go to the left, though, in that condition, which is really beneficial shifts generally. You get big lefty puffs as you head to this headland, right? And that's because the sea breeze is sucking in more easterly. The only reason the wind is shifted so far right and so steady on the right side of the course is because it loves to follow this channel, right? The pressure fills in this way and kind of builds up against this shoreline and is compressed and just funnels in line with this channel. Wind loves to follow channels. So in the southeast, wind blowing in this direction, the right side of the course, we expect to see steady pressure and a gradual righty potentially. More, you have to check the big picture forecast for that. And then as we head to the left, lots of puffs, lots of lulls, lots of shifts, but if you play them right, that's generally the faster way to go. If you're mid-fleet or if you're deep in the race, it could be hard to chase because you're not going to be able to pick your lanes. All the leading boats are going to take the best lanes, and you're probably only going to have light spots and headers available to you if you want to have clear air. But if you're leading the race in these conditions that are closer to onshore than channel, then you want to generally head to this shore and pick the puffs and the lulls, or generally just the puffs and the lifts. Avoid the headers and the lulls. But there's going to be crazy transitions in pressure that you can benefit from by tacking on the lifted tack and pressure. And then same thing, just opposite tacks if the wind's northeasterly, right? You have steady pressure out here and puffs and lulls that are going to, create opportunity to find gusts and lifts as you get closer to the shoreline. So that's why I say this race course is very interesting. It's very dynamic, but it's also predictable. And it's not random, right? There's actually we can actually make sense of these variables. So, yeah. Now, let's go back to our briefing here. One thing an earlier version of this said was that earlier in the morning, the wind's going to be more stable with fewer oscillations and a more predictable pattern, fewer gusts and lulls. And I asked it, why is that? And it's because the thermal heating and the introduction of, that thermal-driven wind has more vertical mixing, okay? The gradient pressure, which is what we're having in the morning, meaning it's just the wind being driven between a high and low pressure, is very steady. It's very, horizontal, and we don't have that vertical mixing because there's no difference in temperature created by the land and the sea yet. Now, as we go through the day and the land heats up and gets a lot warmer than the ocean, now we know that that wind over the land, or that air over the land, is rising with that heat, sucking in new pressure. In relation to that, the cold air out high in the ocean is coming down and, bringing gusts with it. So that thermal heating created a lot of vertical mixing. All of a sudden now the wind's moving vertically up and down, creating a lot of gusts and lulls and headers and lifts. So expect the wind to be more stable, more steady in the beginning of the day, and as we head into the peak of the middle of the afternoon, when it gets the hottest, we're going to see much more variable conditions with way more gusts and lulls and righties and lefties. Overall, I think on the East Coast compared to the West Coast, you see a lot more of that. We can dig into the why of that later, but it's something to look at. Walter sailing out yesterday was probably, mid-afternoon, in that kind of time period, and then also with an ebb current, where it was wind against tide, creating that really, really short, steep chop. Okay, so we know when the wind and tide oppose each other, it creates that short, steep chop. Which, one, we need to learn how to sail that mode. It's super critical for this regatta. Two, it can be a good signal to judge more or less current, right? If we know that the current and the wind are opposing each other, the flatter areas of the race course are going to be less current, and the areas of the race course with bigger chop are going to be increased current. So yesterday, Walter sailing directly in line with this arrow, the wind kind of more southeasterly this way, and the current ripping out here. Ebb current. So in the ebb current, we still have less current in this shallow water cone, but it's not fully blocked. Okay, in the flood current, it's entirely blocked. So there's really significant relief here in the flood, with pumping current on both sides of it. Yeah, okay, so that's ebb against tide, vertical mixing, that's good. Dang, I feel like my first briefing was better. I'm overthinking this one as I go. Going through it a lot faster, though. I guess I talked about it a lot already. So let's go back to the second forecast that came through for today. Showed the wind more directly easterly, kind of just straight across this venue, 90 degrees to the channel. Okay, so if the wind is 90 degrees to the channel, it's going to be, it's flooding now. At noon, it's going to start to ebb. Okay, so it's going to start to ebb opposite the way the mouse is moving, not the way it's pointing. That's right? Yep. Okay, so at 3:30, we would expect max ebb, max current going out, ripping out this way. And so if the current's 90, or if the wind direction is 90 degrees to the channel, I don't think you're going to be getting more or less current relief necessarily by going right or left. The latter rungs are, in line with the water getting shallower. So you would be sailing into shallower water at equal rates, whether you go right or left. And we want to double check that on the Garmin map and really get into a higher level detail about it. But if the wind is 90 degrees to the current direction, coming this direction while the current's going this direction, then we're not thinking about relief. We're not thinking about one side of the course is relief, one side of the course is more current. We're thinking more in terms then of sailing up current first, right? We sail up current first, and the current pushes us to the middle of the course, right? We sail down current first, we get pushed to the ley line, and we run out of options. Okay? And so that's kind of a good way to think about this race course, is we have we have two different directions the current goes, this way or this way, and the wind can obviously come from any direction, but we can summarize it by being in line with the current, right? Because it's either directly in line with the current or directly opposing the current quite often, because the wind likes to funnel in line with this channel. So it can be, quite close to that quite often. Or it can be 90 degrees. If it's coming straight offshore, then it's 90 degrees to the current. And then it can be 45 degrees. Obviously, it can be anywhere in between these places, but I'm just trying to summarize it for you guys. So if the wind is coming in at 45 degrees to this current channel, that's where it gets more interesting, right? So we have to understand all the variables then. In the northeasterly coming this way, wind-wise, steady pressure, giant puffs ripping down this channel, and great shifts to play on the right side, but light spots, and then vice versa on the southeasterly, really, really good pressure coming straight down the channel this way, but you're often better off playing this side of the course heading to the shore, because you get giant lefties and good shifts when you get there. And then factoring in all of that, what you also have to factor in all of that is the current direction, right? So in the northeasterly, if the current's ripping this way, that's fighting you as you go to the left. So that's like, okay, for sure we're heading right then and trying to play the shifts up the beat. If the current is actually flooding in the northeasterly, now we actually want to head and go for the consistent pressure with the flood combo that's pushing us upwind on the left side of the course, whereas on the right side we would have too much relief, right? On the southeast, same principles apply, just in reverse. If the current is flooding, we want to head to the beach. Current relief plus good shifts, good puffs, good lulls. Okay. If the current's ebbing in the southeasterly, now we want to head into the channel. Okay. Great consistent pressure and the current pushing us in the right direction that we want to go. Okay. And then we can have any, wind direction in between all those points. But I think that's a good summary. We could divide it up into kind of quadrants here, where we would have in line with the channel, right? 45 degrees, directly onshore, 45 degrees, and in line with the channel again this way. And we can kind of come up with a summary of each of those conditions. And then we'd actually have to do two summaries, because the current would make it opposite one way or the other, right? But I think hopefully you guys are smart enough to make sense of all of that and think through all the principles that would apply. Then we'd add in a third phase, which would be transition between the current, which makes it more complex. So that's why I'm saying super complex dynamic venue, but it's not like a lake where it's, I don't want to, I guess, say any venue is random, but some venues there's really not good signals. There's crazy shifts and puffs and weird stuff happening, but not good signals to figure it out. Here there's a lot going on, but you can actually predict it and forecast it and put some order to it and understand what's going on. So I really like this venue for that reason. Let's go to the big picture wind now. We have a very nice, neat, organized high pressure over Ohio. These are like very clear isobar lines with the wind going clockwise around this whole knuckle of the East Coast. And we're in this very, very interesting area. Here's our race course in here. And I've seen this the last few days, this weird kind of lighter air system here. We've got two pressure streams converging. We've got a localized high pressure off here, right? The wind doesn't know what it's doing here. It's got the wind rotating off this high pressure coming at it this way, and then the wind that's cycling around this one coming at it more southeasterly, and the two are kind of converging, but I guess they're converging in a high, otherwise they would be converging together and making a lot of pressure. Now, as the land heats and we have thermal enhancement, that's when we see, so this is gradient pressure. This is high and low pressure driven earlier in the morning. And then as the land heats up and we have thermal heating, we see that light spot kind of go away a little bit, right? And you can see out in the ocean here, it's still here. but closer to shore, because the land heats, it's all of a sudden a lot more even. It does look like in the big picture we have better pressure northerly to the north and potentially lighter pressure to the right. But yeah, that's the big picture kind of wind for the day. We should, big picture is pressure better northerly, but it's going to fill and clock right. Okay, so I think even though we see, if we zoom out a lot, we see better pressure to the north, maybe zoomed in because of the way the wind fills, veering to the right with every puff, the right's still going to be strong. And so let's zoom in here all the way as much as I can. I don't like the color to disappear. Okay, so it's nearly that straight onshore condition. Okay, this is 3 p.m., 4 p.m., 5 p.m. Yeah, so very much 90 degrees to the direction of the current today is at least the forecast. So with the current ebbing going down this way, that would suggest, maybe playing the left so that the current pushes you into the middle of the course, right? That's a guideline, not a rule, and that's the reason, so that the current pushes you into the middle so you have a longer period of time to play the oscillations. If there's a giant righty, you'd still rather go right. You just have to be careful not to overstand the mark. But if it's oscillating back and forth and you go down current first, you're likely to end up stuck on the ley line and out of options. And then early this morning, it'd be flooding, so it would be the reverse. And then you'd have a weird transition period around noon, where it'd probably be more effective. I would imagine just think there's no current and you're playing the wind, but who knows? We could get eddies or something funny like that. So let's really keep an eye out for that. All right, I'll try to end here, I think. So we can cover the boat speed stuff in person. Yeah, that's good for now.